The speed race is back, and this time, it's about to rewrite history. Lockheed Martin's Mach 6 state Route 72 Darkstar could soon become the fastest plane on Earth, outpacing every aircraft ever built, including the legendary state Route 71 Blackbird. Designed to fly at more than 4,600 miles per hour, this hypersonic marvel could cross continents in minutes. In this video, we'll explore how engineers made this possible, why it matters, and what this breakthrough means for the future of flight. At the heart of the State Route 72 story lies an audacious engineering goal: creating a reusable aircraft that can travel at Mach 6. This means crossing the United States in less than half an hour or reaching any continent in a fraction of the usual flight time. Lockheed Martin's Skunk Works, the same advanced division that built the State Route 71 in the 1960s, is behind this groundbreaking project. The State Route 72 isn't just a faster version of the Blackbird. It's an entirely new class of aerospace machine. Its most revolutionary component is the turbine-based combined cycle (TBCC) engine. Traditional jet engines work well up to about Mach 2.5 or 3, but at higher speeds, they can't handle the heat and air compression. The State Route 72 overcomes this by merging two propulsion systems into one: a turbofan for takeoff and subsonic flight, and a scramjet, supersonic combustion ramjet, that activates as the aircraft accelerates beyond Mach 4. This transition is what makes Mach 6 flight feasible. Engineers have reportedly completed initial testing of the TBCC system using smaller experimental prototypes, validating the concept that an aircraft can smoothly shift from jet power to scramjet propulsion without stalling or overheating. This allows sustained hypersonic travel using atmospheric oxygen instead of heavy onboard oxidizers. But achieving these speeds isn't just about propulsion. It's about surviving the physics of flight itself. At Mach 6, the air around the fuselage compresses and heats to over 1,000 degrees Celsius, enough to melt conventional metals. The SR-72 structure will likely depend on advanced composite alloys, titanium blends, and carbon-carbon materials similar to those used in space vehicles. Engineers are developing new thermal coatings and heat-resistant surfaces that maintain integrity even during prolonged hypersonic cruise. The design also draws on stealth principles pioneered by the State Route 71. Its smooth, blended contours minimize radar reflection and manage heat distribution evenly, helping the craft endure long-duration flights at extreme velocity while reducing visibility to detection systems. In a sense, the State Route 72 is more than a successor. It's the technological heir to decades of research in stealth, aerodynamics, and propulsion science. So, why is this aircraft drawing so much attention worldwide? The State Route 71 Blackbird, introduced in the 1960s, revolutionized reconnaissance and high-altitude flight. It flew higher and faster than any other operational jet, collecting critical atmospheric and surface data at speeds over Mach 3. But technology has since advanced, and new challenges, such as detecting and monitoring rapid global developments, demand even faster, smarter systems. The State Route 72 could fill that need. One of the most significant advantages of hypersonic flight is reaction time. This could transform how humanity studies severe weather, tracks environmental shifts, and supports future space-related infrastructure. By combining atmospheric flight with near-space altitudes, the State Route 72 could function as a bridge between aviation and space exploration. Its dual-role capability is another major evolution. Unlike the State Route 71, which was purely for observation, the State Route 72 concept is envisioned as an intelligence, surveillance, and reconnaissance (ISR) platform with potential for modular missions. It might carry sensors, data collection systems, or autonomous payloads for research or satellite servicing. This flexibility makes it a key tool in a new era of aerospace applications where speed, altitude, and precision all intersect. This also extends into scientific exploration. Hypersonic platforms could sample atmospheric particles at extreme altitudes, test new communication systems that operate through plasma layers, or even serve as technology demonstrators for future spaceplane development. By mastering sustained hypersonic flight, engineers move one step closer to creating vehicles that can travel from runway to orbit using only air-breathing propulsion for part of the journey. The significance of the State Route 72, therefore, goes far beyond being the fastest plane on Earth. It represents a new dimension of human capability, a step toward making Earth smaller and space more accessible. It's not just an aircraft. It's a symbol of what continuous innovation can achieve when boundaries are challenged. While the State Route 72 promises a revolution, it faces an equally monumental set of challenges. The first is heat management. At Mach 6, air friction can turn any exposed surface into a furnace. The aircraft's skin must handle continuous temperatures that exceed those found on a spacecraft during reentry. Developing materials that can survive this without degrading over time is one of the largest engineering puzzles Lockheed's Skunk Works must solve. Next comes engine integration. The TBCC engine must flawlessly transition from turbine to scramjet mode mid-flight, a process that involves changing airflows, fuel injection rates, and ignition timing in fractions of a second. Even slight errors could cause engine flameouts or destabilization. Engineers are working on automated systems that monitor thousands of parameters simultaneously, ensuring stability during the switch. This precision engineering pushes the limits of computational control systems and onboard sensors. Another challenge is cost and development time. Hypersonic research requires specialized testing facilities, wind tunnels that simulate Mach 6 conditions, high-temperature materials labs, and advanced computational fluid dynamics modeling. Each of these adds complexity and expense. Estimates suggest development could surpass several $100 million before a working demonstrator takes flight. The secrecy surrounding Skunk Works projects makes exact figures hard to confirm, but industry analysts agree it's one of the most ambitious and costly aircraft programs currently under development. The human factor also matters. At hypersonic speed and high altitude, the cockpit environment becomes extreme. Pilots, if the aircraft is crewed, must be shielded from G-forces, radiation, and heat fluxes. The Blackbird's pilots once wore pressure suits similar to those used by astronauts. The State Route 72 would likely require even more advanced protection, possibly integrating partial automation so that human oversight focuses on navigation and systems management rather than manual control. Then there's the timeline of testing and validation. Lockheed Martin officials have suggested that a smaller demonstrator aircraft might fly first to prove the propulsion and materials concepts before a full-scale State Route 72 is built. Industry observers predict this could happen by the mid to late 2020s if progress continues steadily. The road ahead is long, but history suggests that every time humanity pushes the boundaries of speed and altitude, it unlocks discoveries far beyond the original goal. The State Route 72 might be the key that opens the next chapter of flight, from the upper atmosphere to the edge of space. The State Route 72 Darkstar isn't just a futuristic concept. It's a symbol of what human ingenuity can achieve when imagination meets engineering. From the pioneering days of the State Route 71 to today's hypersonic dreams, the pursuit of speed has always been about more than distance. It's about curiosity, progress, and possibility. Whether the State Route 72 takes to the skies in the coming years or serves as a blueprint for something greater, it reminds us that the limits of flight are meant to be challenged. To dive deeper, click the link to watch our full video and don't forget to like, share, and subscribe. Thank you for watching. See you there.